Welcome to Spring LIB.
So in this question, we have this figure 19 of section 7, and we want to consider a sinusoidal wave traveling down the two-part chord. And we want to determine a formula for the ratio of the speed. So V heavy over V light. And B for the ratio of the wavelengths of the two sections. Lambda heavy over lambda light. And we also need to answer why the frequency is the same. Why is frequency the same? Part C is wavelengths larger in the heavy chord or lighter. Oh, that's something we can answer once we figure out what part B is. So let's look at part A. We already know that the velocity in a chord is ft over mu. So right here, it's a continuous stream, so we think they have the same tension. Then the velocity is proportional to the square root inverse of their mass density. And this expression, when we check it, it does make sense because VH corresponds to the smaller value because the density of the lighter string is smaller, and so because VH is proportional to that, that means the heavier the chord, the slower the wave will travel. And that makes a lot of sense to us. And now we look at part B. So the frequency has to be the same in both sections. And the reason is that because if we look at the graph, we have the joint of it, it's connected. So if the frequency is not the same, there's a joint between the two sections. It won't be able to keep the two sections together, because what if it's vibrating like 10 times per second on the left hand side, but it's only vibrating 1 times per second per right hand side? So this won't be we won't have a continuous movement anymore if they have different frequencies. So it has to be the same frequency, and once we have the same frequency and we already know the relationship of the velocity, then we can find the relationship between their wavelengths, because V equals lambda times F. So the relationship between lambda is the same as the relationship between the speed, which is mu L over mu H. So from this, you can see that the lighter chord actually has a greater wavelengths, and the heavier chord has fewer wavelengths. So lighter chord has larger wavelengths.